Linux file permissions are the foundation of system security. They control exactly who can read, modify, or execute every file and directory on a system. Every file and directory is governed by 3 categories of users: the owner, the group, and others. The owner is the individual user who controls the file. The group is a collection of users who share access. Others covers everyone else on the system. Each category can be granted 3 types of permissions. Read allows viewing file contents or listing a directory. Write allows modifying or deleting. And execute allows running a file as a program or entering a directory. When you run lsl, the first 10 characters of each line encode the file type and all its permissions. The first character indicates the file type, a dash for a regular file, or D for a directory. The remaining 9 characters form 3 triplets: owner, group, and others, each showing read, write, and execute in that order. Octal notation compresses each permission triplet into a single digit. Read carries a value of 4, write is 2, and execute is 1. You add the values together for each category. Read plus write plus execute equals 7. Read plus write equals 6. Read plus execute equals 5. Permission 755 breaks down as owner gets RWX, group gets RX, and others get RX. This is the standard setting for directories and executable programs. The owner has full control while everyone else can read and traverse but not modify. Permission 640 means the owner gets read and write as RWMash, the group gets read only as R, and others get nothing at all. This is typical for configuration files that should be private. Only the owner can change them, the group can read them, and everyone else is locked out entirely. The chmod command changes permissions on a file or directory. You can use it with octal numbers like chmod 755 or with symbolic notation like chmod u plus x to add execute for the owner. The chown command changes who owns the file. It reassigns the owner and optionally the group. On a multi-user system, permissions are the barrier between one user's data and another's. A misconfigured permission, like 777 on a password file, exposes sensitive data to every user and every process. Proper permissions enforce the principle of least privilege, grant only the access that is needed, and nothing more.
We begin by creating a simple text file using the echo command. This file will serve as our sandbox for exploring Linux permissions, which dictate exactly who can read, write, or execute data on your system. Using the long format listing, we can inspect the file's metadata. The initial string of characters represents the permission bits, while the columns following show the current owner and group, which are both set to our user agent. By applying the +X flag with chmod, we grant execute permissions to the file. This is a common step when preparing scripts, as it tells the operating system that this file is safe to run as a program. Now we use numeric mode to set permissions to 755. This grants the owner full read, write, and execute access, while limiting everyone else to read and execute only. It is a standard configuration for shared binaries. Setting the mode to 640 creates a more restrictive environment. Here, the owner retains read and write access, the group can only read the file, and all other users are completely locked out from interacting with it. We now elevate our privileges using sudo to change the file's owner to root. This demonstrates how administrative control can be transferred, effectively removing the original user's ability to modify the file's permission settings. Using the : syntax, we simultaneously update both the owner and the primary group to root. This ensures that the file is fully managed by the system administrator, isolating it from standard user accounts. The chgrp command allows us to modify just the group ownership. By assigning the file to the agent group, we allow members of that specific group to access the file without needing to change the root ownership. The stat command provides a deep dive into the file's inode information. Beyond simple permissions, it reveals timestamps for access, modification, and status changes, which are vital for auditing file activity and system security. Finally, we restore the file to the agent user and apply a standard 644 permission set. This configuration is the default for most files, allowing the owner full control while providing read-only access to everyone else.